because it was hard. Once again, I don't think the level you guys were at were math mature quite yet. They understand that. They're cutting back their secondary math too. You guys are the guinea pigs for us, I'm telling you. Because we haven't done this class yet, right? It's the first time we've ever taught this class. Last year, secondary 2 was the first time ever taught, so we're trying to ease ourselves in. Okay? Does that make sense to everyone? So, I'm just telling you that people in secondary math 2 this year, honors, are not going to have as much as you guys did. But that might help you now for the future. On this one, it might be a whole lot easier, whereas next year it might not be. Does that make sense? So, there's a give and take. Okay? All right, so first off, we're doing 4-1. We're talking about radians and degrees, okay? Now, just like everything, if you really think about it, if we were born in Europe, would we have a hard time with the metric unit? Well, no. The reason why is because that's standard. That's what would be normal to you, correct? So growing up, degrees was normal to you, right? Now, in mathematics, radians is what you go with, okay? So maybe even last year they let you do a lot of stuff in degrees. It's not going to happen, okay? As you sign up for calculus next year, they don't hardly even use degrees in calculus. They use radians. So today we're going to once again convert radians. Does anybody have some earplugs that I can borrow those for? I don't know what they're called. I just need somebody's. Because how many of you guys truly know what a radian is? The definition of radian. Awesome. That was good. Thank you for letting me have my phone. Call her Kelly. Call her by her real name if she wants to be called by.
Yeah, I'm always a public
Okay. So, we all know what's a whole circle if we do it in degrees. It is 360, right? Now, Austin, you did say something, correct? Okay, he's talked about a whole circle being 2 pi radians. Well, first off, let's talk about what the hell that even means. Okay, what does a radian mean? Does anybody know a definition of a radian? Okay, not book-wise, I'm just asking. Okay? Does anybody really know what a radian is? I'm asking, seriously. Okay. Huh? It's just a different way to measure, but this is what it is, huh? Radian. Watch this, guys. From here to here, what's that called? This is called your radius. If it's tight, that tells you if I start at this point and drew a circle, it goes all the way around, equal distance from the center, correct? Okay. That's flexible. Moving around. See how I can actually put it on the circle? Start at 0. Now, obviously, I'm having a little bit of a hard time with it. Okay.
Watch out for cold.
You're going to mark off everything I do, okay? Alright, so once again, I'm going to find this circle's not perfect. We all understand that, right? I'm not an artist. I'm not making a perfect circle. Okay. So what I'm going to do is I'm going to put this radius, curve it. That distance is considered 1 radian. It is your radius on the circle. That's what a radian is. So therefore, that angle measurement, so if I brought that in, that's considered 1 radian. Because that is the length of 1 radian, or 1 radius on the circle. Okay? So now I'm going to go around. Okay, now obviously this circle isn't perfect, but look, there's 1 radian, 2 radians, 3 radians, and a little bit. That's 2 radians and a little bit. It's pi, hence why a half a circle is pi radians. Does that make sense? Did you guys understand that last year? Does that make more sense? Okay. That is how many radians it takes, or how many radiuses it takes to get to half of your circle, no matter how large your circle is. Okay? Because if you put that radius on the outside, or the circumference that's talking about the length, right? You start going around, that length would take pi radians, or pi of your radius, however long it is. Does that make sense? Does that give you a better understanding? Okay, so we're going to continue around. So once again, what's 6 in a little bit? 2 pi. Okay? Now, that will happen for however large or small your circle is. That's where pi came from. Is this number kept coming up, and this same ratio kept coming up every time on circles. It doesn't matter how large or how small, you take your radius, and that's how large, you go 2 pi around, that'll give you a complete circle. That's what it is. That's what a radian means. Okay? So for me, I really didn't understand that until, like, to be honest, 7 years ago. And then I'm like, that makes a whole lot more sense where this is coming from. Because most of you guys, how many of you guys think that radians always have to have pi in them? I did. I'm like, radians always have to have pi. But the reason why a lot of them have pi, okay, is the fact of the matter is you're cutting something that has a circumference of 2 pi into increments. So hence, that's why there's a lot of pi in it. But, notice where's 3 radians? Right there. There's such thing as 3 radians, right? There's such a thing as 4 radians. Okay? It's okay, and that kills a lot of people. Like on our tests that I've had in the past, I'll ask somebody to convert 7 pi 6, which is in radians, right, to degrees. And I ask somebody to convert 3 radians into degrees. They can do the 7 pi 6, and they're completely lost. They can do the exact same thing. But because it doesn't have a pi in it, people freak out. Okay? So understand, there are radians that have just a specific number of measurements. Okay? Everybody good with me? We're feeling okay. Now, this is very important to convert, because we all know, once again, this is also 0 and 360, right? Degrees, correct? We also know this would be 180 degrees, correct? So there's equivalence, right? Where did I read? So, are you okay with the radian? Okay. Well, so can I get to that question in just a little bit? It'll flow in just a little bit, and I'll show you why. Because not every angle measurement is exactly 140 degrees, right? Not every angle measurement is perfect, correct? You agree with that? So therefore, there's going to be some things that work exactly the same. I'll get to it when we convert. I think that'll answer your question pretty well. Okay? You all right with that? Okay. Does everybody so far feel okay? So this would be what up here? 90. This guy would be 270. Notice, if I take half of a circle, pi half. Is it 90 half of 180? Or is it 90 half of pi? So pi half, right? I'm also increasing by pi half, so there's pi half. 2 pi half, which is 3 pi halves. This guy down here would be 3 pi halves. Because notice I'm just continually adding pi halves as I go. If I add it again, quadrant would I be in? 4, right? Because remember, just for those that might not, 1, 2, 3, we go counterclockwise, don't we? Okay? 1, 2, 3, 4. It would be in quadrant 3. You guys said 4, excuse me. So we're going to go ahead and draw that. So with that being the case, I'm going to draw the axes. I'm going to start this side. Does anybody know what this side is called? It's not the terminal side. Very close. There is going to be a terminal side. This is called the initial side, meaning the starting point, right? Initial means in the starting point, correct? You'll always start there, won't you? Okay? So then, you guys tell me to stop. That's a little farther than I want to go, but okay. And I really don't care how accurate you are. Okay, if that's 300 degrees, can somebody tell me what this measurement is? How did we do that? Well, we know a whole circle is 360, so we just cut back 300 from 360, and that tells us this is 60. Correct? Okay, now, James, what is this side called? This guy right here is the terminal side. Okay? So you have the initial side and the terminal side. Now understand, later we're going to build triangles, right? The unit circle, I don't know if you guys know this, is a bunch of triangles. Okay, and we're going to do that, we'll see you next Wednesday on that, I think. Okay. What's today? Wednesday. Yeah. So I'll see you in a week. That's because Monday's no school, and I'm not being here Friday, so I get to travel 10 hours to go to Cody, Wyoming. And my sister comes. She's getting married. She just graduated. Well, she graduated in I figure I got 4 more times to go up there. My other cousin's wedding. 3 times. My other cousin's wedding, and then when my aunt and uncle got it. That's more time than I need to get there. I hate driving. That's forever long. Every time it snows, snow in Wyoming is death. They don't salt the road. They start to snow. Huh? No, it's a good story. Everybody needs to know. Okay, so, how many guys remember from last year co-terminaling? Anybody remember what that means? Nope. Nope, not sine, cosine, none of that. Co-terminal. How does it come back to this? Here's your terminal side. It's other angles that end up exactly on this line. Such as, let me give you an example. Negative 60 degrees is co-terminal to 300. Are they the same angle measurement? No. But do they end up on the same terminal side? Yes. That's a co-terminal angle to 300. Usually what I like to do is get a positive coterminal and a negative coterminal. Can somebody also give me another example of a coterminal angle that might be positive? 70 would be the terminal side would be here. So that would work. Go with it. 660 would be another. Can you explain where 660 degrees, these two would be considered coterminal angles of 300 degrees? Now here's a perfect example, okay? Some people yesterday didn't quite get it. Now, if I was judging snowboarding, Sean White, the Flying Tomato, you guys all get him, right? He gets up there, and he does a one person does a 360 and the next person does a 1080. Right? Who'd you be more impressed with? Because there's more work in doing that, right? They end up the same spot, so why does it matter? Because they're different angles, aren't they? So technically they are different angles, right? But they end up at the same spot. Everybody with me on that? Same kind of thing with a coterminal angle. Negative 60, we went back, because remember, going clockwise is negative angles, correct? So therefore going backwards would be negative 60 coterminal. How can I get back to this if I want to continue on? Remember, if I continue on, so this is already 300, right? So how do I get back to that? I add 360 to it, don't I? Right? So how do we, what's a good rule to get coterminal angle? Ends at the same side, right? But you add or subtract 360 because you're getting back. A full circle gets you back, doesn't it? Just like here. Here's a little visual. I am standing at 300. Boom. How do I get back here? I can add 360, 660, right? Or I go backwards 360, and I'm here. Correct? That's the idea. I once again rotated. Could I get more coterminal angles? Yeah. What would I continue to do? Keep adding and subtracting 360, right? Does that make sense? Yes, sir. Yeah, that is, but usually I'm looking for a positive and a negative. But negative 420 is also coterminal to 300. Usually what I'm going to probably look for is one positive. Okay? Yes?
Always has to start again instead of
Does everybody feel okay? That feels pretty natural, doesn't it? Because this is what we grew up with. This is like our foundation. Correct? So now I'm asking you to switch to the metric system, basically. Okay, I'm switching you to the radian. So if I asked you, somebody, where would, oh, that's more. Where would 4, 5, 5 be? Anybody tell me which quadrant? I heard third, I heard some second. It's a little bit more, we could still do it. Your guys' brains are very functional. It would be in the second, and here's the reason. Okay? Now notice, this guy's 5, right? So therefore, that would be 5 pi. This would be 5 halves. If I got a common denominator, they both need to be at 10. This would be 8 pi tenths, and this would be 5 pi tenths. So obviously it's in between here and here, correct? Everybody understand? Now, how many guys would like to just maybe still think in degrees? So isn't it nice to maybe, now once again, I'm going to be honest with you. Hopefully at the end of this unit that we go through, if I tell you something like, what is 120 degrees? Boom. I want you to say 2 pi thirds. If it's on the unit circle, you need to know just like that, like it's a multiplication table. Okay? And I'm going to quiz you a couple times on the unit circle so that you can memorize these things. Because, once again, how many of you guys do a lot of your adding and times in on the calculator? How many of you guys get amazed when all of a sudden I'll divide something and times something? I don't know how to do that. Let's be honest. How many of you guys get a little amazed by it? Okay? I thank you for being amazed. Second thing, the reason why I do that is it keeps your mind ready to go. A lot of the times, you guys understand the math. What you guys don't understand is you're like, how'd you get that number? I divide it. It's not the math you got struggling with, it was the stupid timesing. Okay? If you guys let yourself, now do I think calculators are great tools? Yeah. You guys use them as crutches. There's a difference. Just like on your homework, I'm going to give you odds, straight up, every time. Very rare will I give you an even, because I want you to check your answer. Just like you did on your homework. Wasn't it nice to know you got it right? Let's be honest. Right? It's nice to know that you're doing things right. Okay? So that's why I gave you the odds. Good old Bob will tell you the answers every time. You guys know what Bob is? Back of the book. He has all the answers. Okay? So, but once again, don't use it as a crutch, use it as a tool. I use a calculator as a tool. Okay? And what happens is I can see things a lot quicker and it allows me to access the math instead of the arithmetic. You guys sometimes struggle with the arithmetic and not the math. So if you let your brain work, instead of letting it just do easy stuff, that helps you. That's all I'm trying to say. Especially if you continue to go deeper. So, treat the unit circle like times table. Know them. Memorize them. Should be reactionary instead of thinking. Okay? When we get to that point. Anyway, 4 pi fifths. So how would I graph that? So I come over here, start the initial side. Somewhere here. Okay? Now, if I'd like to be a little bit more accurate, what could I do? I need to convert into radians, right? We're actually in radians. Sorry, we're going to convert to degrees. Okay? How many of you guys have taken chemistry? I don't know if physics does it, but a lot of you guys usually do if you're in this type of class. You guys are in the more challenging science classes. Okay? With that being said, somebody tell me, without telling me the answer, the process of 36 inches, I want to know how many feet. It's called the dimensional analysis, right? Train tracks. Okay? Go ahead. Multiply by 12. So I'm going to put 1 foot up here and 12 inches down here. Now, I don't know about you guys, but I've been taught I can only multiply by 1 to not change the value, right? That's not 1. It is, though, isn't it? How is it 1? Okay, this is what I'm saying. Because technically, we want to know what 36 inches is in a different unit. So it's the same measurement, right? Different. So it's basically timesing by 1. We don't want to change the value. We just want to get it somewhere else, correct? Just like 2. I want to get that to maybe divided by 5. So that would be 10 fifths. I changed it, but it's the same value. I multiplied by 1. Right? This isn't multiplying by 1. How is this allowed? Because it is 1, technically. Even though they are not the same number, they are equivalent measurements, correct? That's the process in unit analysis, correct? Dimensional analysis, whatever. You get what I'm saying. So therefore, the inches would cancel, hence why the inches are downstairs. Okay? And then notice that would be 36 feet divided by 12, which then ends up being feet. Something very simple we all understand, right? How many of you guys have done dimensional analysis in the class? Anybody really not? No? Does that make sense? Okay, so we're coming back here. And what did I have 4 pi fifths? Is that what it was? 4 pi fifths. Unit analysis. I want to go from one unit to another unit. So what are we going to do? What's our equivalent statement? Just like in there, 12 inches was 1 foot. That's the same mark. So what do we know? Go ahead, Ethan. Awesome. Did I use anything else? I could use 2 pi and 360. Why would I not do that, though? Well, not really. It's just 2 pi, 360. I can reduce. That's really easy. I would use pi and 180 and then we'll reduce. So just to let you guys know, that's why we use this. It's not, like I could use many things, right? On unit analysis, do I have to use 1 inch equal, 1 foot equals 12 inches? Could I use 2 feet equals 24 inches if I really wanted to? Well, I could, but once again, we like to use the simplified things, right? Everybody good with that? So what are we going to multiply 4 pi fifths by? Anybody want to know? Oh, yeah. Just ignore, how much? Close. 180 degrees over pi. And technically after pi, what should we write? Radians. Because it's pi radians. Now, in math, we see technically pi and we're doing trig, we already understand it's in radians. A lot of times we don't write it, but technically, should we write it? Technically should be there. Huh? I scribble. Okay? But understand, I just want to make sure you guys understand that. Because it's not that we're getting rid of the pi and radians. In this case we are. But like to answer Stevens, I'll do that in just 1 second. We're going to do what? Okay, we're going to convert 3 radians, and I'll show you why it's important to do 3 radians. So once again, you have the pi radians cancel out. So notice what I personally was taught when I was younger was to always simplify my fractions before I multiply, because then you're not into large values and you can do it more in your head. Okay? 180 divided by 5 is 36. Okay? 4 times, so 4 times 36 is 144 degrees. So, and once again, that's getting in larger numbers. So yeah. Sure, fine. What's 4 times 180? That is 720. Divided by 5. How many times does 5 go to 7? Once, and then notice I'll have 22. How many times can 5 go to 22? 4. How many times? There's 2 left over. How many times can 5 go to 20? I'm doing long division in my head. 4. Amen. Okay. Awesome. So 144 degrees. Did this picture look like 144 degrees? Okay. What if I asked you for what is coterminal to 4 pi fifths? Because I'm going to do everything I do in degrees, I'm going to do in radians to start to convert you to my side, right?
6
Whoa, 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 whoa.
Negative 6 by 6.
Why? Whoa, I don't understand. Right, why? Okay, so you're here, so you want me to get back to here. So you're telling me to go this direction, which is 360. How did you get negative 6 pi fifths from 360? Initial. And how do you do that again?
Because I know that that closer was
Oh, okay.
and then you subtract what
I get what you're saying. Okay. So, once again, what did we do when we were in degrees? How do we get coterminal length? We added and subtracted 360, right? Didn't we? So what are we going to do here? We're going to do it with 2 pi, right? Because that is equivalent. Now, could you go to 144 and add 360 and subtract 360 and then convert it back to radian? You could. That is a lot of work, so I would work here. Okay, if you correlate the idea, why we're consistently for adding 360 with degrees, we were comfortable with that. Be comfortable with, okay, what's the equivalent of 360? 5. So that's what we're doing. So what I do is, getting coterminal equal to 4 pi fifths, I add and subtract 2 pi, so therefore I get a common denominator, correct? Now you might be able to do this in your head, that's awesome, you did, right? I can think about a way that you did it, I don't know if you really did that about it. Okay, so then notice, what's 4 pi plus 10 pi? 14 pi fifths. That's coterminal, right? Is everybody with me on that? And then 4 pi minus 10 pi is negative 6 pi. Are you okay back there? Notice this is also something that I saw in your version. I already know this is 5 pi fifths, right? No, it's more. 5 pi fifths, so that's 6 pi. I thought, is that kind of what you were doing?
I pretty much thought it's 2 pi fifths times 4.
Cool. Does everybody understand? Awesome. Okay, so that's the same thing that you didn't understand with coterminal. You were kind of a little off on it. Because you asked me to go negative 420, right? Okay, why did you want to keep going negative? Okay, no, but that's the same fifths, that's just another coterminal. If you wanted to get another one, you could go 24 pi fifths, 34 pi fifths. Okay? Just keep adding or keep subtracting if you want to. Did I answer your question? Yes, 14 pi fifths and negative 6 pi fifths were your coterminal angle to 4 pi fifths. Okay, sure. I'm good? Alright. How many of you guys remember some of this stuff? A little bit? At least sweeping some cobwebs a little bit, maybe? Awesome. Hey, next one. Here we go. I want to help Steven over here, where he doesn't believe we can have just 3 radians. Huh, Steve? And I'm not saying you really believe that, but... 3 radians. Okay? So notice, what am I going to do? How do I convert this to degrees? Times this by what? See, this is what confuses people, and I don't understand why. It's the same idea. What is our... Just like if I wanted to convert feet to inches, inches to feet, I use the same conversion tool, correct? What's our conversion tool? 180 degrees equals pi radians, right? So who goes on bottom? What do we want to eliminate? The radians. So therefore, I put 180 degrees on top, pi radians down below, right? So therefore, cancel, cancel, and you get 540 pi degrees. Now, we like seeing that as a degree. Plug that in your machine. I bet it's close to 180. I bet it'll be 170 something. What is it? 171. Exactly. 171.88, and it keeps going, obviously. Because not every angle measurement is perfect. Right? Does that make sense to you a little bit more? The pi? Because there was none. It's not perfectly like, you can only cut up a circle. Not everything goes exactly even, right? Not an exact angle measurement. Whole numbers are exact angle measurements, right? And usually when I reduce, I'm still going to have a pi in it. Right? But what if I get to, you know what I'm saying? Like it doesn't go exactly incremental measuring it. Right? Not everything lands on degrees, do they? Same kind of idea. So go back to our very first example. That guy right here. 1 radian, 2 radian, 3 radian. Doesn't that look like 171.88 roughly? I mean, like I said, roughly. Right? No. Okay, so what you're telling me to do, so like what you're trying to tell me to do, okay, is something like this. Could you really have pi over 2 inches? Let's be honest. Right? I could. So let's say, okay, I want to go to feet again. So notice I'm going to have 12 inches and 1 foot. Okay? So then the inches cancel, and then you're like at pi feet over 24. Now, what you're saying is like, oh, this has nothing to do with it. I'm out of that realm, and I'm like 24 inches, that's 2 feet. So that's the same thing as pi over 2 feet. That didn't make sense what the hell I did there, so don't understand that. But what I'm trying to say with you is, okay, maybe what I'll go back here. Could you kind of think of maybe on this one, right here, just substitute the pi with 180? Because you're converting from a degree to an angle measurement? Sure. But in this one, there's nothing to substitute in for at the beginning. I think I'm answering your question to that point. guys feel comfortable finding angle measurements, like drawing an angle measurement in both radian and degrees? Okay. How many of you guys feel comfortable switching back and forth? You're okay? How many of you guys feel comfortable with finding coterminal angles? I think are we feeling okay? Any of those questions? That's a lot of your homework today, so I want to make sure. Once again, graphing angles in both radians, degrees, converting back and forth, and finding coterminal angles. As long as you're in the right quadrant, I'm good to go. No, last time, remember, so let's say, that's because we're out, so far we've been going radians to degrees, so let's go degrees to radians. Give me a degree measurement. 67. This is going to be the easiest one I've ever done. Nope, this is awesome.
Why did it be harder?
67 degrees. Okay? So I'm going to convert. So therefore, I'm going to go pi over 180, just for the same fact. Those radians, 180. Why do I want 180 down below? Because then the degrees would cancel. Just like here, if I had 3 feet, right? I want the 12 inches up top and the foot down below so that you can't cancel. That's the whole idea about dimensional analysis. Yes. Because those are, basically this is timesing by 1. Right? So therefore now, I'm at 67 pi over 180 radians. So that's not going to reduce. Okay? Now, angle measurements have seconds and they have 3-second minutes. I'm not getting into that.
Oh, yeah, sorry.
Okay. No, you're good.
I just...
Is everybody okay so far? We've got a little bit more time. The next thing I'm going to ask you to do is we're going to go ahead and talk about circumference in a way. But it's actually called arc length.
Oh.
Okay? And see, you guys already don't have a distaste. Because maybe you weren't explained the way that I have now, because at first I thought it was really hard. It's not. It makes a lot of sense. Okay, does anybody know what an arc length is? You got a circle, right? What they tell you is, this should make sense if you just understood what a radian meant, because your arc length is always in radians. Okay? What it means is you have to have an angle and a radius. Why do you have to have the radius? Because then now we'll know how big the circle is. Because remember, your radius dictates how many radians it goes. Always, how many radians in the ram? 2 pi, but, and that's if, what would be my circumference if my radius is 1? 2 pi radians, right? But what if my circumference is 2? It would be 4 pi, because it's going to be a little bit longer because my radius is longer, right? But it's going to take 2 pi of your radiuses to get around the circle. Yes, no? Isn't that our formula for circumference is 2 pi r? Right? They are taking how much of the circle you want to do. I want to get all the way around the circle. What angle is all the way around the circle? 2 pi. Then you times it by your radius. That's what circumference is already. It's an arc length. It's a special arc length. It is. It's just a special arc length. Just like it isn't a square or rectangle. It's just a special rectangle, right? Circumference is just a special arc length. No, you're okay. What's the because there's definitions. You never took geometry. In geometry, there's definitions. What it has to be is, first off, it has to be a parallelogram. Parallelogram means 2 sets of 2 sides that are parallel. Okay? The rectangle, square, follow that. The second thing is that 2 sides or opposite sides of that parallelogram are curved. Yes. call them ovals, we call them ellipses. A circle is a perfect ellipse. Anyway, we'll actually get to ellipses and things later. Okay, so here's this. Now watch, guys. Here is your formula for arc length. I don't know why the hell arc length is S, but it's S. Okay? Arc length is S. I don't know why. Some dude was smoking pot. I don't know. Maybe they thought it was just a weed whack. That's funny. Anyway, watch. Here's your formula. You guys ready? R times your theta. And that should make sense, because, look, R times your theta. Theta's an angle. How much of the angle do we want to go around for a circumference? The circumference, the whole circle. So what angle are we using? 2 pi times the theta. So therefore, what if I don't want to use the whole circle? What if I only want to use 120 degrees? Well, first off, our angle is always in what? Radians. So therefore we convert, but think about this. This is actually a very simple conversion. Okay? How long does it take, how much is 1/20 of 2? A third of it. So is it a 1/20, a third of 2 pi? So 2 pi third. That's another way to do it. Don't be looking in your dang book. Do some conversions. I love you. 2 pi thirds. Yeah, because 2 pi is a whole circle, and isn't 120 a third of the whole circle? So there's our angle. Let's say this is 5 inches. What's our arc length? The arc length, by the way, is this measurement. 2 pi thirds times 5 inches. So therefore, what's your arc length? 10 pi third inches. Is that really that hard? It's very simple. Think again. Think about if you were taught arc length instead of circumference. Then when somebody taught you circumference, you're like, that makes sense. Right? Really think about it. If you were taught in elementary arc length instead of circumference, when somebody actually showed you circumference, you're like, why the heck did you show me that? That makes sense. That's realistic. That's, yeah. Right? So think about how they correlate. That's kind of, for me, what I kind of clicked with that they're the same equation, basically, right? One, I'm not using the whole circle, I'm only using a part of the circle, so therefore I'm only using that angle measurement times my radius. And that should make sense, because that's the radian measurement, but then I have to times it by my radius to figure out how far that radius was to get around. Right? Okay. So, we're doing good. I know you guys might feel a little worn out, but hopefully feel good. Okay? Yes. Theta is just a thing for angle. Yep. Hi. I didn't take that. Maybe that's probably what happened, Sharon. Because remember that Tuesday that you thought, or that Wednesday you thought I was on? I probably took it off this one instead of that last one. Because that makes more sense now, because I know, no, because I remember, like you said, that I was on this one. I know I took it off. So I think that's what happened. I'm okay. Yep, that's fine. A copy. But that makes more sense why you were freaking out that day, because I'm like, I took my name off. I have no idea why. No, but that's probably what happened. I took off this day instead of. Yep, I'm on. Yes. Okay, so very good question there. Answering yours. Coming back, theta is an angle, but angle is always in radians. That's what it is. You might want to write that down just to make sure you're good with it. Theta is an angle, always in radians. Yes. So I had a student yesterday. She had her notes from last year. She's like, Mr. Roberts, this doesn't make sense. This isn't what I was taught last year. It is. You guys were they were still keeping you in degrees as well. So what the equation they gave you was converting the degrees into radian already in the equation. Does that make sense? I said, I like your jacket. Are we feeling okay? Sir? So like, for example, see how it's 120 degrees? I'm not putting that 5 times 120. I'm doing 5 times 2 pi thirds, because 2 pi thirds is 120 degrees. Does that answer your question, Brian? It's very simple, right? Okay. So, I'm going to mess your world up in circumference. Now I'm going to go mess your world up in area. What's the area of a circle? Maybe remember? Pi r squared, right? How much are we finding? The whole circle, right? You guys want to see where this formula came from? Area is 1/2 theta r squared. Because notice, what was our angle to get all the way around the circle? 2 pi. We cut it in half, what do you get? Pi. This formula, these formulas come from these ones. So if they would have just taught you these ones instead of the other ones, you wouldn't have a problem whatsoever. Now we're blowing your mind, because then you're like, why did they taught that earlier? Right? Okay? But, does it make sense? Here is the formula. If I don't want to use the whole damn circle, don't. Okay? Put your theta in, however much you're using, and that's your equation.
So use the one on the right, not the one on the left.
Exactly. I'm just saying, this is what you've been taught your whole life. Right? But, if you just learned this would have came along. Right? Okay? Yes, sir. No, okay, so once again, 1/2 theta, but once again, what is this formula for? A whole circle. What's the angle of a whole circle? Which is in radians what? So therefore, if I did 1/2 of 2 pi, are we good?
That's like
So therefore, let's use the same thing. Okay? I give you 120 degrees. This guy's 5 inches. What is the area of the sector? That means this shaded area right here. That's what that means. Because I'm not using the whole circle, I only want a part of it, right? Which is called a sector. Okay? So therefore, we already know what theta is. What's theta? Thank you, Austin. I love you, brother. Area equals 1/2 of 2 pi thirds times 5 squared, which is 25. 25 pi thirds inches squared. Okay. 1/2 from the formula. 2 pi thirds is the same thing as 120 degrees. We converted it on the previous one. 5 squared. 2's are gone. 1 times pi times 25. Kachiga. 1 times 3 times 1. Kaboom. Inches, inches, inches squared. It's well, you haven't done it for a year. Right. It's not, well, inches squared. Anything that's area is always unit squared, and that makes sense because you're taking technically 5 inches squared by 25 inches. If it's feet, what's it going to be in? Love you, Bronson. Jamesy James.
That was my question.
Okay. The only other thing, guys, is sometimes we give you the area of a sector, or we give you the circumference, not circumference, the arc length. So, for example, what if I said your arc length is 6 inches, and your radius is 2 inches? Okay? What's your angle? So we can plug it back in. S equals r theta. Or you could understand, we're missing theta, aren't we?
Yeah.
So isn't theta S over r? Yeah. So S is 6 inches over 2 inches, which is 3 radians.
Another radian measurement, that's really important.
Just put it back in for a bit different. That's your answer. Theta's 3 radians. No, 3 radians. I don't care about degrees. Your mind, by the end of it, I'm done with you, I want to convert you without degrees. Think in radians. When you want to put an answer down, you will think it needs to be a radian. Okay? Right with you. Exactly. They're doing a 1080, you're saying that's a 6 pi-er, man. You know what I mean? Okay. Are we feeling okay? All right, here we go. You're going to write your homework